Hello students, today we learned more about earthquake resistant buildings and we also mentioned a different topic, which is that of how earthquakes tell us more about the earth inside. Let's start off with earthquake resistant structures. Once your notes are set up, go ahead and write number one. Here's number one. So there's two forces that are acting on a building, two major forces. So compression is a force that pushes down on an object. So in this picture right here, and you don't have to draw the picture, for now, I just want you to look. You can see that the gravity is pushing down on the building, and then tension is the force that's acting on the sides of the building. So for that second part, right, tension is a force that pulls an object apart. So buildings made out of noodles or made out of steel beams, they all deal with these two forces of compression and tension. Here's another image so you can kind of see it. So the weight of the board and the weight of gravity pushing down on the board is compressing the board. It's making it kind of squished, if you think about it that way. And then because this top part is being squished right here, and this bottom part is being kind of moved apart, and that's tension. So that's something to think about as you build. How far are your support beams from your actual building? Maybe if you move it closer, there's going to be a little bit less compression and less tension. So again, something to think about as you build. All right, the original sentence, it's not going to show up here, but this is the one you can write. You can write compression pushes down an object. So you can say what is compression, or you can say what is tension. So again, what is compression, or you can write what is tension. All right, let's move on to number two. The post and the lintel. We talked about that as a lecture today. It's a building structure that spreads out the force of compression. So you notice here, it looks kind of like a C that's facing downwards, and the force of compression is minimized through a post and lintel. And you can interconnect post and lintels. For example, I see one here. You see this post, and there's lintel. So these two are called the posts, and this top part is called the lintel part. And it's even supported with some cross bracing here. So you can interconnect post and lintel to make a structure even stronger. All right, go ahead and think of a question for number two. Once you're ready, move on to the next one. All right, ready? Let's move on to number three. We know all about the inside of the earth, or the earth's interior, because of how earthquake waves travel in the earth. For example, we know that only primary waves can go through the whole circumference of the earth, like in this picture here. Let's look at it in more detail. So as you see, and this is on your handout today too, there's a primary wave and the secondary wave. And then you can see when an earthquake happens, the wave is traveling through the earth, but because of the liquid part of the outer core, you can see some of the waves kind of are refracted or bounced, and eventually they change directions. And then you can see some waves like this green one, which is the secondary wave, doesn't even go. It hits here and it just disappears, because secondary waves can't really travel through liquids. So we know a lot about the earth because of waves, the way primary and secondary waves travel. We know which layers are which. We even know how thick they are, most likely because of the way they travel, or which waves travel and which waves don't travel. All right, go ahead and write number three. If you need another minute, pause it, because I'm moving on to number four. Don't forget the question for three. One of the areas we talked about was the shadow zone. And it depends where the earthquake happens, but the shadow zone is an area where there's no waves at all. And it's because either the primary waves are reflected, or because the secondary waves never made it through there. Let's look at this image again to look at that. So here's the shadow zone, and you see in the shadow zone, here's the waves traveling, and some of them get absorbed, some of them get reflected. But it's an area that the waves don't just appear because of the way that waves are reflected or absorbed. But if the earthquake happens over here, let's say in Brazil, here's Brazil, then the shadow zone would be somewhere around here and somewhere around here. So it's just an area where the earthquake does not register, depending on where it started. Okay, go ahead and finish up all the notes. Make sure you have a question for four, and then move on to a summary and advanced question, and then have a good day.